we are going to apply knowledge of bearings, sine rule, and SOHCAHTOA, or the information that can be described as being taken from this phrase SOHCAHTOA, to this problem. The problem is points A and B are 100 meters apart, as depicted here on a coastline. B is directly east of A. There it is. A lighthouse is out at sea. Look at that lighthouse there. The bearing of the lighthouse is 160 degrees from A and 216 degrees from B. The angle of elevation at the top of the lighthouse from A is 27 degrees. So we're going to tackle these two problems. The first problem says find the distance of the lighthouse from A. The second, find the height of the lighthouse. So what have we been given? We have been given the bearings at A and B, and we've also been given the angle of elevation. We've also, one other major point that we've been given is there's 100 meters between there. That will be advantageous as well, of course. So how can we begin? The first thing to recognize is what therefore we know, and we know information about bearings perhaps. That is to say, when you're dealing with a bearing, we want to look or perceive the concept of north, assuming that north is this way in this diagram. That is a norm. That is a norm. That is a normal circumstance. Therefore, we can say that the angle, bear with me on this curvature here, from here to here, from A, 160 degrees. So you stand at A, you look or understand north, and then you move clockwise around 160 degrees. That is the bearing concept. Given that, there's more information that we can tackle. For example, we can aid, or we can utilize, I finally got it, it's utilized. There's 90 degrees there, of course. So if this whole thing's 160 degrees, what I have suggested, what I have stated here, is that if the whole thing is 160 degrees, then 90 degrees is taken up by that much, leaving only 70 degrees here. So we are able to state very comfortably, perhaps, that this is 70 degrees, and therefore I say the angle at A is 70 degrees. We can do the same thing, and I'm going to do the same thing just swiftly here, straight up looking north. The angle here, let's get this little paintbrush out, it goes much further out clockwise, of course, because it's a bearing. There we are, we're at 216 degrees there, which makes sense because it's a little over 180 degrees, which would be completely south. Henceforth, one thing that we can recognize is that's 90. So of course, if I do my little square, let's bring this square back. There is 90 degrees. But here is 90 degrees as well. So a more interesting one might be to consider that this here is 90 degrees. Now, the whole thing is 360 degrees, right? One full cycle, 360 take away 90, you got 980, you're left with 270 degrees. So that is 3/4 of the way around is 270 degrees. So all of this movement in here is 270 degrees. I'll make that a little bit clearer perhaps with a dark blue. So here, I need a paintbrush, not a square. For all of this movement, I'm going to move my brush round to here. All of that is 270 degrees, right? 360 take away 90. So this is 270 degrees. And we know that all of this red one in there was 216 degrees, like so. And as a result, we can say that if we do 270 take away 216, we'll be left with this section in here, which means I'm comfortably able to state that the angle in here is 54 degrees, and that will aid in us being able to solve this problem of the distance from A to the lighthouse in the next video.